Couldn't we start? Good morning, class. Last class we had done about the classifications and preparations and uses, properties of acids and bases. Now individual bases and individual you have only one, that is ammonia, that I will be doing in the next class. Just now application of strong and weak alkali. So for strong alkali, analytical, it's called analytical chemistry. We use this strong and weak alkali. One means ammonium hydroxide and sodium hydroxide. Sodium hydroxide is a caustic alkali and ammonium hydroxide is a weak alkali. It has a wide application in detection of cations. The positive ions, that is the metal ions, can be detected by this strong and weak alkali. So first of all we will see some colored ions. You know that sodium, potassium, calcium, these are all white salts. Ammonium, these are all white salts, they do not have any color. But there are some salts which have color, some cations which have color and some anions which have color. So cations, copper 2, that is taken you showing, this is copper sulfate, this is copper 2 sulfate, show this in. Copper 2 sulfate, this is blue in color, okay, it's blue in color. And then we have iron, Fe2 plus, iron in ferrous state, oxidation state is 2. Ferrous sulfate is green in color, that way, green, light green in color, ferrous sulfate. Then we have ferric, iron in the third oxidation state is 3, ferric. It's like this, it's yellowish brown, actually brown, this has turned dark, but it's actually yellowish brown in color. Then we have nickel salts which are green in color. I'll show you the nickel salts. This is the nickel salt which is green, this sort of green it is, green in color. Nickel salts which are Ni2 plus, green in color. And next is cobalt, chromium. Chromium is also green in color, and I have not written over here, that's a cobalt, CO. Cobalt is pink in color, this sort. You have read in the test of water, cobalt chloride paper is used for testing of water. So this is the cobalt, and Mn is also pink. So these are the colored cations. These are the colored cations. Now you have the colored anions. Permanganate, pink, permanganate. Permanganate, here, permanganate. If I add water to this, you will be able to see the color better. See, this is the pink or purple color of permanganate. So permanganate MnO4 minus, it is pink in color, pink or purple in color you can say. Then we have chromate, chromate ion, CrO4. Chromate is yellow in color. Even if you add water to this and you make a solution, the ions are yellow in color. See, it gives a yellow solution. So chromate ions are yellow in color. And then dichromate. Dichromate ions are orange in color. Here I made a solution already. This is potassium dichromate solution. So dichromate is orange in color. So these are the colored ions: nickel, green, cobalt, pink. Then the other cations: copper, blue, Fe2 plus, green, Fe3 plus is brown, reddish brown, yellowish brown, whatever. The rest of the salts are white in color. And now we will do the detection. How do we, in a solution, how do we detect these salts from the precipitates they give in a caustic alkali? First we do the caustic alkali with NaOH solution, how these salts react. So we will show the practical application, and the theory is already written in the book, in the board over here, sorry. So first we will take, the first is calcium nitrate. Okay, let's see what happens when you add calcium I have taken calcium here, and to this calcium I will dilute it a little. Then I will add NaOH to this, sodium hydroxide to this. So a white precipitate is formed, a thick white precipitate is formed, and this precipitate is insoluble. If I throw it out, if I throw this out and take a small amount of PPT and try to dissolve it in excess of alkali, this will not dissolve. This is insoluble, it will not dissolve. So it is sparingly soluble, it's almost insoluble, sparingly soluble or insoluble in excess. This is a thick white precipitate of calcium hydroxide which is formed. Calcium salts, calcium nitrate, when treated with NaOH, it is giving a white precipitate which is insoluble or very, very slightly soluble. That much of precipitate you can't see, but it's very, very slightly soluble or almost insoluble in excess of the reagent. And what is the reagent? The reagent is sodium hydroxide. We are taking a caustic alkali. All right, next is ferrous sulfate. We take ferrous sulfate. Ferrous sulfate, now the reactions always take place in solution form. This solid ferrous sulfate, if you add, it won't react. So any ionic reactions, they will take place, ions will be dissociated in the solution only. So the reaction will take place in let's dissolve this ferrous sulfate properly. And to this ferrous sulfate, when you are adding NaOH, this is iron 2. Let's see what happens in excess. Nothing. So this is a gelatinous dirty green precipitate. See the difference of the green. This nickel was looking a different green. Okay, so there are different shades of green. This is a dirty green. It's called dirty green precipitate. Green with a blackish tinge to it. So dirty green precipitate, and when we are adding excess, even if we throw this and take a small amount and to that we add excess, it is not soluble. It is not so insoluble in excess. So ferrous Fe2 plus ion, it can be in the question, it can be asked Fe2 plus ions also. So Fe2 plus ions or ferrous ion, and this is Fe2 plus state. So it is giving ferrous hydroxide FeOH2, and this is dirty green in color, insoluble in excess. We saw that it is insoluble in excess. Next is ferric iron, but it is in +3 state. So it is Fe3 plus. You may be asked to distinguish between ferrous and ferric ion. How do you distinguish between ferrous and ferric ion? So if the salt is giving a dirty green color precipitate, then it is ferrous salt, and if it is giving a reddish brown precipitate, then it is ferric salt. So let us see what happens to the ferric salt. We will take this ferric salt. So directly to this I will add this is the solution, ferric chloride, and to this we are adding excess of, we are adding first precipitate is formed, a dark brown precipitate. You can see it settling down at the bottom. It's a dark brown, you can see it's sticking to the walls of the test tube, dark brown precipitate. This is formed. Okay, so reddish brown precipitate. The precipitate, what is the color? See, observe the color very carefully. It is reddish brown precipitate. Reddish brown, we call this reddish brown. See what is sticking to the glass, that is reddish brown precipitate. Now what we do, we throw this, and to the little when we are checking for the solubility of the precipitate, we take a very small amount of precipitate, and to this we add the reagent in excess, and then check whether it is soluble or not. It's not soluble. Had it been soluble, it would be a transparent solution. So it is reddish brown precipitate, insoluble in excess of reagent. So the color difference you could check very well. What was the color of the ferrous ions? Was dirty green, and ferric is reddish brown. Distinguishing, you can do the with ammonium hydroxide also the same reaction will take place. Means not the same reaction, but the resultant is same. Means you get a dirty green precipitate because there also ferrous hydroxide will be formed, ferric hydroxide will be formed. So the distinction you can, ferrous and ferric ions you can distinguish with NaOH or NH4OH either. Now we come to copper sulfate. Copper sulfate I just showed you. This is the solid copper sulfate. It is crystalline blue in color. CuSO4.5H2O. Now we will take a small amount of this copper sulfate. And we will make a solution of it. We can decant out the clear liquid from top. So this is copper sulfate solution. This is copper sulfate solution, and to this solution we will add sodium hydroxide. This is sodium hydroxide. Okay, the analytical, the reagent that we are taking is sodium hydroxide, a caustic alkali. When we add sodium hydroxide to this, what is the color of precipitate formed? A blue precipitate. A pale blue precipitate will be formed. So copper sulfate plus sodium hydroxide gives copper hydroxide. Okay, this is in +2 state, Cu2 plus. Okay, Cu2 plus. Cupric. Actually, this is cupric ion. This is also cupric ion. So the precipitate looks like this. It is a blue precipitate. A pale blue precipitate is formed, and in excess it is insoluble. If we add excess of reagent to this, it is still insoluble. You can see just the amount of the precipitate is increasing and it is insoluble. Even if we shake it like this, it is insoluble precipitate. You let it rest for some time, you will see that the precipitate is floating now.